Hello and welcome to another episode of Rawkode Live. I am your host, Rawkode. Today we are going to be taking a look at Pixie, an open source tool for zero code instrumentation of Kubernetes and your applications. Now before we take a look at that, there's a little bit of housekeeping. If you are not already subscribed to the YouTube channel, I would encourage you to do so now. Click subscribe and click the bell and you will get notifications for all new episodes of Rawkode Live. Every week I try to explore as much of the cloud native ecosystem as I can to bring you all of the knowledge that you need to learn this mess together. And of course, we have a Discord server available at rawkode.chat. If you want to chat about Kubernetes, cloud native, rock music, or anything in between, come and say hello. There's over 400 of us in there now, chatting away, having some fun. All right, now Pixie. In order to guide me today, I'm joined by Natalie Serrino from the Pixie team. Hi there, Natalie. How are you?
Hey there, doing great. How are you doing?
I'm very well, thank you. Thank you for joining us today. Can you just take a few moments to share a little bit about you and tell us who you are?
Yeah, totally. So I am Natalie. I am an engineer on the Pixie team. Pixie was acquired by New Relic in December, and so part of that company as well. Before I came in the observability space, I was in the data space. So I guess that's my little micro background and wanted to go look for interesting data problems. And I think observability is a great example of one of them.
Awesome. Yeah, there's definitely a lot of data in the observability space, especially as we are starting to see more teams and organizations adopt microservices with distributed tracing. Like that data is growing at crazy rates. So.
Yep, and like most data problems, collecting the data is half the battle.
Yes, definitely. And let's just start talking about Pixie because I'm really curious. This has been one of the most requested technologies that I've been asked to cover on this show. So I'm really excited to bring this to people. But it says here on the website that we can instantly debug applications on Kubernetes and it doesn't require any instrumentation. Do you want to share a little bit about that?
Yeah, I think that that's a really exciting thing about Pixie that drew me to working on the project in the first place, because I think that, historically there's been a lot of challenge with collecting the data that we need in order to successfully debug our production systems. And, what myself and the other members of Pixie found in the past is that debugging your developer environment is one thing, but debugging a production environment is completely different. And it feels like you're riding blind a lot of the time. And we'd like to have access to a lot of the same data that we can easily get in our development environments. So I think that was kind of one of the initial inspirations for it. And, this coincided with the, kind of popularization and, adoption of eBPF in the Linux kernel, popularized in large part by Brendan Gregg, who has done a lot of amazing work in the space. And I guess just a little bit of background on eBPF for people who aren't as familiar with it. It's basically, I think of it as a way of registering hooks in the Linux kernel. So anytime you open a file, or anytime you drop a packet, or anytime you receive a request on the network, all these things you can put hooks into and tell the kernel to run a function that you register with it. And that actually has huge benefits for things like security, where you can use it to put in really advanced networking rules. But it also has great implications for observability, because it basically gives us a handle on the total state of your system without having to put any code changes or anything like that in to collect that data. And we found that we can collect a very rich set of data, and we're only scratching the surface. We can use eBPF and Pixie to automatically collect full body requests made by anywhere in your cluster, DNS stuff, MySQL, Postgres, and also things like network statistics and system metrics. So we're really excited because in basically what you'll see as a pretty quick deploy process, you basically get all that information immediately when it would have previously taken months to get.
Yeah, definitely. I think eBPF is just one of the coolest technologies that we have right now. There's so much cool stuff you can do with it with regards to these probes and the kernel hooks and such. And I had never really thought about it before as an application for collecting telemetry, but it's like without having to modify my code. But what? Now that I've seen Pixie's website and I've heard you talk about it, I'm like, yeah, like why wouldn't we do this? Because the kernel is our application as an interface to the kernel. Like we already know what's happening at some level within that stack. So let's emit metrics from it and other things. Okay. Also, there says here, I should really just show my screen, shouldn't I? Let's pop that up. There was oh no, it's gone. There was a banner at the top that says that Pixie is moving to the CNCF as well. So the Pixie is completely open source and soon to be a CNCF Sandbox project. Is that correct?
Yeah, I'm really glad you brought that up because it's, recent news and we're so excited about it. So I guess just like a little historically, Pixie was originally a startup. And then when, we decided to partner up with New Relic and, join them, we were really excited that they shared our vision of reaching even more developers than before. And, in this space, open source is really important for people. People really like to build on top of open source stacks. And so we were really, really happy that they shared our vision of turning Pixie into an open source project. And with the CNCF, with the amazing caliber of projects that they have in the CNCF, we're so thrilled to be a Sandbox project that was, made a formal a few weeks ago that they've decided to accept us as a Sandbox project. And so we're really excited to have, tighter relationships with those projects and also just show our commitment to remaining a truly open source project. Pixie is entirely open source and licensed under Apache 2.0, and it's going to stay that way. So that's our commitment to our users that is what the situation is going to be going forward. And joining CNCF is a good way to show that.
All right. So everyone watching today has the opportunity to learn Pixie, use it in their own applications, and never have to pay a dime, which I think is pretty sweet. And they don't have to use New Relic, just to clarify, right? Like you can use Pixie without using New Relic at all. So New Relic are essentially just helping Pixie grow, but not integrating into product or something like that. Like Pixie is its own thing, right?
Yeah, it's a good question. So, if you were wanting to use the purely open source, like self-hosted version of Pixie, all of those components are available and we have docs on how to get started with that. We also have a version of Pixie where the cloud component is hosted by us with a very, very generous free tier where, if you want to do a little bit less legwork in getting started, then you can, have us host the cloud side of that. Now, New Relic has really awesome integrations with Pixie, but Pixie is its own thing. So you don't have to use New Relic to use Pixie.
Awesome. Okay, shall we get this installed into our cluster?
Let's do it.
All right. Now, I can already tell from the homepage here, we have every developer's favorite curl bash. Is that the way that you wish to install it today?
Yeah, if you go into our docs, you can see that there's other ways to install as well for people that prefer other modes. But I think that, if you go to install schemes, and you can just click on the parent of that, install schemes. Oh, yeah, never mind. It just did what. But we have Helm-based and, YAML-based installs as well for people who prefer to go that route. But I think that for the purposes of this, I think that I recommend starting with the bash-based install.
Yep, you don't have to convince me. I'm sold. Okay, so this is obviously running on my local machine. So is this going to install Pixie CLI to my machine? Is it going to install something to my Kubernetes cluster? What should I expect here?
So what this is going to do is install the Pixie CLI locally to you, and you're going to authenticate with, we use Gmail or G Suite for authentication in this version. So hopefully that's okay, and you have a personal Gmail account you can link it to.
Yeah, no problem.
So it's going to install a CLI and then basically ask you to sign up You'll want to sign up actually, unless you've logged in before.
Yeah. Okay. Good catch.
Yeah. Sign up with Google. And then if that's a good Gmail for you, then that's great for us. Oh, maybe you have actually signed up in the past. Oh no, okay. Sorry, it just lagged. Okay, looks like it worked. Okay, sweet.
Yeah, it might be okay.
And so, basically the Pixie CLI has a lot of stuff that you can do. The first thing that most people do is install Pixie itself onto their Kubernetes cluster. But before you do that, I just want to point out that we have like two modes that we can install Pixie. One way that, is kind of the default, and it uses persistent volumes, and PebbleDB is the backing store. But we also support a version that uses the etcd operator, which doesn't require persistent volumes. So I think that for this cluster, what we might want to do is use that version of Pixie.
Yeah, okay. Happy with that.
Because I think that you mentioned that the persistent volumes may need to be set up. So let's just skip that and just go straight to it.
Yeah, I'm okay with that. This is a bare metal cluster, and I do provision Rook on them, but it's definitely not something I'm happy to try and debug live. So if there's a no PVC option, I'm definitely going to grab that.
Yeah, so if you do px deploy --h, then we can see the deploy options. So what you have there is all the options for the px command. So we can see that -o gives us use etcd operator. And that's the one that we are, looking at right now. So let's see what happens.
Okay, so that's all I need is just that flag to say use the operator. Nothing else is required.
Yeah, it's going to try to deploy to your local Kubernetes context, your current context. And so if you need to switch contexts, then, that would be something good to do.
Nope, I am on my Pixie 1 3-node cluster, so we should be okay.
Okay, great. Okay, so this is okay because this is a bare metal Kubernetes cluster, which should still work even though it's giving you a scary warning message, and we like to ride dangerously.
All right.
So just say yes.
Life on the edge.
Life on the edge. Quite literally, because Pixie actually collects and stores all of its data on the edge rather than shipping it off to a cloud.
Okay. So it's creating a namespace, looking for a previous installation, I guess, and cleaning up. Now we're getting some secrets and some config maps. I guess this is just
Pixie is like a Kubernetes, it's a set of Kubernetes services basically. And so we have some dependencies like, we'll be deploying nats and etcd, and then also deploying the, what we call the Vizier PEM nodes, which are the ones that are responsible for actually deploying the eBPF probes and collecting the data that you can query.
Okay. Well, I'm a big fan of nats, so that's cool. So I'm assuming we've got collectors that are publishing messages to nats, and then are those being consumed by some sort of workers? I'm just going to guess how your software works now, sorry.
Yeah, no, it's a great question. We're also really big fans of nats as well. So basically, what we have is a PEM node will be deployed on, or a PEM pod will be deployed on every node in your cluster, unless you have something like a taint that blocks it. And so these PEM nodes are going to deploy the BPF probes and start collecting data and storing it, within the PEM. So the data is actually not being sent over nats. It's actually just being stored on the node that it exists on, because we really want to be a low burden to the network and just kind of keep data where it's collected. That's one of the things that, we're trying to do. So, but, we use nats for lots of different stuff, like communicating the current state of the PEMs and make sure they're healthy, or sending messages about Kubernetes metadata that, the PEMs need to be aware of when a query is run.
Right, okay. Well, it looks like everything has deployed, and now we're waiting for those PEMs/Kelvin.
Yeah, so basically at this point, all of the prerequisites for the cluster have been deployed, and now the PEMs themselves are being launched. Kelvin is, you can kind of think of it as like the collector node, because when you run a query, you may be asking about data on multiple PEMs at once, and they need a common place to send it to for the reduced stage of the query, if you think of it that way. So Kelvin fulfills that role.
Okay. We have a question in the chat, which I'll throw up for you. But Noel is asking, what is Sentry?
Oh, yeah, that's a good question. So Sentry is something that allows us to track errors in Pixie when people run into problems. I think that, that is something that is going to be optional. So people can kind of choose if they want to let us know when they're having some kind of crash.
Yeah, I think I've used Sentry before. It's like an SDK you can bundle in your application, which catches exceptions and then throws them off to the Sentry thing, and you can keep an eye on them and see how often they recur and such like that. It's a really cool open source tool as well, I believe. So.
Yeah, it's a really good way of finding out, what your problems are and what problems your users are running into that you may not be hearing about.
Yeah, in a former life, I used to work on Android and iOS apps, and we always bundled Sentry, and it's overwhelming in that context when you've got enough users. So I don't recommend it for that use case.
So it looks like it's successfully deployed, which is great. The demo gods are with us. So I don't know if before we use the UI, if you want to try running a query in the CLI, just to kind of show off the fact that you don't even have to leave the terminal.
So just to clarify then, right? Like that PX deploy-o has done everything. We're now collecting telemetry from this cluster.
Yeah, that's right. So previously, where you might have had to spend quite a bit of time investing in the data collection, it's basically been entirely done for us in this process. You can always extend the data that we collect. We have the ability for you to deploy custom BPF traces and things like that. But, right out of the box, you get access to all of your HTTP requests, your SQL requests, your CPU usage, how loaded is your network, just with this one command.
Okay. So you suggested we can do something on the command line here to actually introspect that in some way. So
why don't you do PX script list, and then we can kind of see like if anything pops out to you as something that's interesting. So there's a lot of results here, but I can also recommend a few if that's easier. But I think a good one maybe a really simple one to do is PX namespaces. Just kind of tells you what are the namespaces that you have running. So if you do PX run, you can just do space PX/namespaces to execute that script.
Right.
So we can kind of see, this is a very simple script. There's a lot fancier ones, but just didn't want to overwhelm people all at once in the CLI. So we can see the different namespaces that we have, the number of pods and services that they have, as well as the resource consumption that we're seeing aggregated by namespace.
Okay, so I just want to make sure I understand this correctly. So PX run allows me to run Pixie scripts. What does a Pixie script look like? Can we look at what that was?
I'm so glad you asked. That's one of my favorite parts about Pixie, actually, because we made it a 100% scriptable platform. And what that means is that the scripts that you write or the scripts that we have provided right out of the box are the thing that you use across the UI, the CLI, and our client APIs. So it's one consistent way to run queries. Pixie's language is Pythonic, so we use Python syntax so that people don't have to learn a brand new syntax. And we were really inspired by Pandas, if anyone's familiar with that, which allows people to, it's a really great tool for cleaning up, preparing, and analyzing your data sets in Python. And we found that all the stuff it does, we also need to do those things. So we decided to just follow their API rather than reinvent the wheel. So when you look at it, it will kind of just look like Python code. if you want to look at scripts, one way that you could do that is you could clone our repo, and I can show you where the scripts are in there. Or we could just open the UI, and then we can always inspect the script that's generating a given view.
Okay, so if I click this link here that it gave me after I ran, okay, let's clarify the most important thing we'll clarify today. The command pronunciation. Is it Pixie or Pix or PX?
I don't know, man. I mean, I kind of like to watch Flame Wars, so maybe we should explicitly not weigh in here and then see if people develop a strong consensus. But I will admit I say PX.
PX. Okay, I'll go with PX. I'll go with you, but the audience can feel free to bring in their own flavor. So let's see if I can actually log in after that little maybe faux pas. Yeah.
Flash.
It worked. Okay, cool.
Yeah, so as you can see, when you run a script in the CLI, you have the ability to click and just access that same exact thing in the UI if you want to send it to someone or something like that.
Okay, so many questions. So there's no data leaving my servers to go to your servers, right? Is this querying my cluster? How does the data transfer work here?
Yeah, let's dive in. So we wanted to store data on the edge that it was collected. We think that is a really good way to lower the network utilization, because in your production system, you don't want to be maxing out your network card sending out telemetry data. So that's a really good thing from a system perspective, but it's also a good thing from a privacy perspective, because Pixie pedal, that's funny. Because, we recognize that, telemetry data is sensitive. And when you keep it where it was collected, that's a way of adding another layer of privacy. So we have two modes with Pixie. The first mode basically uses Pixie Cloud as a proxy, so that when the UI has a query, it proxies it through Pixie Cloud. And in this form, the data is always traveled entirely encrypted, never persisted on the Pixie Cloud side of things. But for people who would prefer that this not be the case, we also have data isolation mode, which basically says when I'm running the UI, I will actually query my cluster directly, and there won't be any proxying. This can have downsides because you always need to be able to access the Kubernetes cluster when you use the UI. And so we think that, both modes are valid, but we default to the pass-through mode because of the user experience it provides, while still maintaining the promise that we don't persist data anywhere else.
Okay, perfect. We have another question in the chat, which is very specific to this, but Vikram is asking, can we run the UI on our own cluster or local host? Is that an option?
Yeah, it is. So if you do the fully self-hosted version of Pixie, and you can, just check out the docs for how to run that, then you would be basically running it yourself.
Got it. Okay, so this is the same representation of what we got on the command line here, where we have a kind of TLDR on our namespaces and what's running in them. And then we've got some telemetry showing us disk throughput and, disk throughput and network stats. I'm sure there was some network there. Maybe.
There might not be. Maybe I should change the script, but I wanted to start really simple because I think this is before we dive into kind of the rest of what's going on here, I wanted to just show the script for this view. So if you scroll up and then you click that little bit, that little cursor, that editor, basically you can see the code that produces this script. So basically you can see the namespaces for cluster function will produce the table that is the top one. It's basically getting a list of namespaces in the current cluster. And then the next one, the next function is producing an overview of the resource consumption by namespace. So these are the two views that we're computing.
Okay. Yeah, it does just look like Python code.
Yeah, and that is by design, because we're making this for developers, and we, as developers, want our observability pipelines to be more like writing code.
Okay.
But for people that don't want to mess with the custom scripts, you don't have to. We have a ton of scripts that ship right off the bat. But we do find that, power users who really like to get into it do enjoy writing custom queries and drilling into stuff that's like especially important for them in particular.
Well, yeah, I guess because, Pixie understands what data is being collected, that you can already produce all these scripts up front that just represent that in the best possible way. So it kind of makes a lot of sense. What's a viz spec? Is this just the display we've got here?
Exactly. It's just telling you how you want to lay out the results of the query. So we have more than just tables, as we'll see if, we go into the cluster view, for example. But with the viz spec, you can specify what type of visualization you want. So I recommend switching to PX cluster because that's kind of like the starting view that we show to people in most cases. And I can walk you through what we're seeing here if that would be helpful.
Yes, I see a graph, but I'm not entirely sure what the graph is representing.
Yeah, so this is our service map. So it looks like we're detecting services on your cluster, but we're not necessarily detecting the services talking to each other. And that can happen when a pod isn't part of a service and it's talking to things. So this isn't, may not be the prettiest graph, but we often see results like that. If you scroll down, you can see the list of nodes. And if you look at the node name, you can actually click that link and actually be taken to a view about that node. So we really want to make a really easy drill down experience for people. And so we have these hyperlinks embedded in our tables in multiple places where you can just click a link to see more about that entity. So here we see the pods that are running on this node, the CPU usage of the node, and other things like the traffic and the bytes.
Nice. I like it when you get shared cursors like this across panels and graphs. Very different in correlation.
Like lining it up like these two things happen at the same.
So this is a bespoke UI, right? This is written just for Pixie. Like, do people have the option to use Grafana if they want, or would you encourage using the Pixie dashboards?
It depends on your unique situation. So we do have a Grafana plugin that's available and open source. So if that's the environment you're comfortable in, you can configure Pixie as a data source and use it to help build your Grafana dashboards. But if you kind of just want a super easy, like you don't have to, set that up or whatnot, you can also just use the UI. And, we think that either one is a good thing to do. But the Flamegraph, I'm glad that's being called out. So yeah, that's something, a new feature we're pretty excited about because, this kind of data can be kind of hard to get in most cases. So we're basically running profilers on your, various nodes and seeing like where is the time being spent. And we have heard that people really like that because it can help isolate bottlenecks.
Yeah, that's pretty nice. I like that. I want to see what other scripts we've got. Oh, I just zoomed. That was cool.
Oh, yeah.
Oh, that is nice. There we go. I kind of wish I had planned ahead and stuck a few thousand workloads or something on this cluster to kind of see more. But we're still getting a lot. I mean, considering this is a really vanilla Kubernetes cluster that's just running the control plane, Rook, and Cilium, we're already getting a whole wealth of information out of this immediately, which is pretty nice. We have a question from Noel, if you want to tackle that. Noel is asking, does this profiling have an impact on, our CPU and memory and such?
Yeah, for sure. So, with these types of tools, we realize that it's so important for us to take as minimal of a footprint as possible while still providing really rich telemetry. Because, I take it very seriously what runs on my production cluster, and I don't want that to be something that in a bad time is eating like 50% of my CPU or something like that. And so with that being said, we target that Pixie will use under 2% of the CPU of each of the nodes. But, just for some buffer room. In practice, we say that it should stay around under 5%, but we're always looking to drive that down.
Okay. Can we confirm that through the what's being logged?
Oh, hell, yeah, definitely. So if you want to go click on the PL Vizier PEM pod in this, you don't even have to exit out of this view. You see that PL Vizier PEM pod?
Yep.
So let's take a look and see if we're living up to that. If not, I can file some bugs. So
oh, wow.
that's a CPU usage for this pod, and it looks like we are staying under 2%. So that 5% qualification, I guess, wasn't necessary here.
Yeah, so we can actually see, we've got all the major stats on this pod and what is happening. Are these
and we get
functions
a
and
flame graph
syscalls?
pod too. Oh, sorry, I think I missed that.
Are these the functions or syscalls that application's calling?
So for compiled languages, we're actually able to get the function names. And so if you're running a C++, C, or Go application, for example, we're actually able to extract out the functions themselves and how much time that they are each causing, not just the system calls.
Okay.
So you'll see a lot of C++ in there because that's what the PEM is made on.
That's pretty magic. I like that. I want to look at something else now. Can I just change pod? Yeah.
You can change pod for sure. You can also, like as you were doing, browse the scripts and see what is up with those.
Yeah, we can definitely take a look at more scripts. So this is our Cilium pod, which handles all of the networking. We can see it's making HTTP requests. I'm curious then, does Pixie understand all the major protocols like HTTP, gRPC, Kafka, or does it not care about that stuff?
Yeah, so anything that uses HTTP, will automatically be traced. So sometimes those protocols will use HTTP, kind of underneath the hood. But we also do support many different protocols in addition to that. And we have a list on our docs page, but I can just rattle off some examples. We support MySQL, Cassandra, Postgres. We support DNS. We support encrypted HTTP traffic in addition to unencrypted HTTP traffic. We have support for other ones, and I'm just blanking a little bit, but if you want to just pull up the docs, we can take a look.
Yeah, definitely. I don't expect you to remember all this off the top of your head.
So if you go to supported protocols at the very top of if you scroll up, supported protocols, Yeah, I forgot Redis. Redis is a big one. And we're always looking to add more protocols. So Kafka is a very interesting one.
Okay, so if my applications, all my cluster where Pixie is deployed is using HTTP, HTTP2, gRPC, DNS, etc., telemetry is automatically going to be collected for me.
Mm-hmm. And we'll also ship Pixie with views that query that data and present it to you in an easy to consume fashion. So support for that protocol also includes scripts that you can easily access.
Okay, that is very, very cool. Okay, so we can see the processes in our pod, network stats.
Yeah, I really like being able to see stuff by container too.
Even just seeing the requests being made, we've got the P99 here. That's just invaluable information when you're debugging microservices. Very, very
and I don't know how easy this is to discover, but if you see those little white tick marks, if you click, let's say the one in the middle of the bar in the latency P99 section. So if you just click another one, is it? Yeah, if you just click that, it switches everything to P50. So now you can see all P50s. So you can drill down into P50, P90, and P99 in this column. And you can sort as well.
Okay, got it. And if I expand it, I can just actually see those values here too.
Yeah, that's useful when you have a lot of columns in the result table and you kind of want to look into a particular record in detail.
Okay. That was impressive. I really liked that.
That's great to hear.
Let's take a look at another script. Do you want me to pick one, or is there something you'd like to take a look at here?
Let's do net flow graph. I really always enjoy that one. And you're gonna have to put a namespace in. So if you want, you can put in PL because I know that one exists, or you can put in one of the namespaces you're interested in looking at.
Do I type one? It's not like giving me
If you just click on if you click on namespace to filter on, is it? If you, so you see where it has the text namespace to filter on?
Oh, yeah. Oh, right. Okay.
Yeah, if you just type PL or default. Default works too.
There we go.
So it's a little bit overwhelming, but what we're seeing is a map of the network traffic that we have in this namespace. And we try to resolve as best we can the places that your different pods are talking to.
Okay, so we can actually see which of the Pixie pods are communicating with one another through all these lines. What's the difference between the blue and the gray kind of node representation?
Yeah, so basically the blue is more like, it's more considered like remote, I guess. So the non-blue is the pod in your namespace, and
Okay.
then the blue is anyone else that it's talking to, because we have that namespace filter in here, and that filters the gray ones. But we know that these pods may be talking to destinations outside the namespace or even outside the cluster, and we want to still represent that information.
Okay. What happens if I click enable hierarchy down here?
Let's see. Sometimes that can be a nicer representation.
Oh, I can zoom.
And drag it around, yep. So now we can see more clusters of behavior.
There we go. That's a bit better.
Yeah, the other one was a little extra.
That's cool. I mean, how does it get like the domain names if it's encrypted traffic? Or is that all it gets? It doesn't get paths and such? I'm not actually sure.
Well, Pixie has access to be able to trace the encrypted traffic when it's unencrypted by the system. So we can actually give you a full request because we're collecting it in the place that it is already unencrypted, if that makes sense.
Yes, okay. Oh, there's a loud siren. Hopefully you can hear that.
No worries.
Okay, so then we've got... so this is just all the requests. Okay, so we can see where the source was, where the destination was, and we've got bytes sent and bytes received.
Yeah, this can often be a pretty eye-opening view for our users, and it can produce some unexpected results sometimes. We often hear things like, wait, those two things shouldn't be talking. What the heck?
Yeah. It's just good getting, like, these are things I think that are so easy to overlook in your clusters that you just, you don't have observability in them, or you just forget, or you're going to do it later. And like, this took me all of 10 seconds to deploy and get this. So yeah, it's very, very cool. eBPF is so cool.
It's really cool stuff, and we're really excited to be building this because, as developers, we're trying to build the thing that we ourselves want. Oh, so this funcs is basically like trying to help the user if they want to compose their own queries and they want to know what functions are available. Now, this also exists in our docs, and I would argue it may be more easily consumable in the docs, but just an example of the type of kind of like helper view that we can also provide in addition to the more typical views.
Yeah, I kind of accidentally clicked on that. It wasn't something I intended to click on. So.
Okay.
But I was kind of, when I clicked on it, I was like, oh, I wonder what this is. And then I had no idea. So I'm glad you explained it. All right, let's take a look at maybe two more, and then we can see what other functionality we have available here.
Maybe HTTP data could be a good one.
HTTP.
Because I think that a lot of times, like, it's good to see the computer results, but I also just love to see the raw data sometimes. And this is a very raw view. It's a little, I would expand a row because it's very wide. But this is the type of information that we're able to collect. We're able to collect the request and response body, the headers, the time, the pod that it happened on, the path.
Yeah, so we've got full visibility into each of the HTTP requests that were captured by Pixie.
Right. Right.
Okay.
And each protocol will have its own kind of equivalent view of just looking at the raw data.
So I'm curious, like, we're using Pixie scripts that are just pre-canned for us. Like, if I wanted to be able to see, because this is, HTTP aware, is it possible for me to see all the 400s or 500s and be able to keep a track of things that are maybe broken in my cluster?
Oh, definitely. So we do capture the codes, and that's one of the ways that we produce plots of like errors per service and things like that. Maybe it would be good to see response status, see 200.
Yep.
So you can write a pixel script that aggregates on response status, or does other things with the code, or counts the number of things that are not success. We do that in a lot of our scripts. And so like any of these parameters that you see, like you can write scripts to analyze. And we hope that the default scripts we provide cover, maybe like all the common cases so that people don't have to do unnecessary work. But if there's something special you want to ask, then, this type of data you can just query on.
Okay. So do you want to do something with that, or do you want to take a look at one more script and then move on to that? What's your preference?
I don't know. Both are pretty good. Why don't we edit this script and just make it only show errors?
All right. Okay. So
let's go to the pixel script.
So sorry, you say, is it pixel script?
Pixel script, yeah. You can say Pixie script too, either one, but yeah, it's technically pixel script. PXL is how it's spelled.
Gotcha. Okay.
So yeah, I think it'll be fun to make a little modification to this script. So basically what this script is doing is it's pulling the HTTP data and it's extracting a little bit more metadata to show in the results, because we're able to resolve things like the namespace and the node and the pod that each request, happened on. And we're also dropping some columns that we don't think are maybe that useful to people. So
I'm assuming, based on kind of what I see, that there's probably like a DF filter. Would that be right?
You're so close, but I'll tell you the syntax. So you'll say and you'll actually, so df equals df, and then we're going to put brackets, like square brackets. And then this is basically Pandas' way of doing a filter, and we're going to put a Boolean condition in here. And that Boolean condition will be used as the filter condition.
All right.
So you want to say
status greater than 400?
Yeah, but the only modification that you got almost perfectly is that you'll do df.resp status, because we have to specify which data frame the column exists on. So let's try running that and see what we see. And if you can collapse that editor, and now we'll see only response statuses that
404.
are. Mm-hmm.
Okay, that's pretty nifty. That's quite a lot. There's actually more than I was expecting.
Yeah,
now, if I wanted to do like an aggregate count of that, is that something I can do in Pixel Script as well? Like
Why don't we count it by pod?
All right. Okay, that sounds good. I'm not going to try and guess that.
We're going to take out the df.head because we don't need that. That's just basically saying I only need 1,000 records. So I'll just walk you through. So you're going to do df equals. Is that equals? It looks like a dash, but maybe it's just not
equals,
resolving.
Yeah.
Okay. And then you're going to do df.group by.
Group by, like that?
It's just just all lowercase, no underscore.
Okay.
And then you're going to do parens. And then in quotes, in single quotes, or you can do double actually too, you'll do pod. So basically this is saying we're doing an aggregate that's going to group by pod. And then after that, after the last paren, you're going to do .ag or agg.
Oh, ag, right, okay.
And then in here, let's name the output column. So let's just say like num underscore errors. it doesn't have to be in quotes. It will just be like a key
Mm-hmm.
argument, and then equals. And then we're going to have like a tuple here. And the first element of the tuple is going to be the input column. So let's just say time underscore. Doesn't really matter because we're doing a count. And then that will be in quotes. And then comma px.count. And so basically what this, and then that will, perfect. So what that's basically saying, and our docs have more detailed information for how to compose these queries if that was like completely alien. It does follow the Pandas API. So there is a method to it, and then the docs basically tell you about all of these different things you can do, so you can use them for reference. But what this is saying is take the pod column and then count the number of errors per pod.
Okay, so will I hit run on this?
Yeah, hit run. We can.
There we go.
And it looks like core DNS pods are the source of the 400 plus errors. So that is something that we learned about your cluster today.
And that's within the last 5 minutes?
Yeah.
Okay.
So you can edit that to be bigger or smaller, but we find that people tend to be most interested in looking at. You made a mistake. We need to work on the UX for this a little bit. You actually have to do negative because it's like a relative time.
Yeah, of course. That makes sense.
But I consider that to be kind of our bad, not yours, because it would be very easy to make that mistake.
Okay. So if someone else wants to learn how to write pixel script, I'm assuming they come into here. We've got, is it just reference?
Mm-hmm. So in operators, for example, you can click on ag and then see, that's what we did.
There we go. Excellent. Okay, let's tackle a couple of questions, and then we'll see what else we can do here. So Suresh is asking, are there any improvements to Go eBPF observability done, and are they available open source? I guess Suresh is asking whether the Pixie team is working on Go eBPF and contributing there. I'm not sure.
Yeah, so I would say that we're more consumers of eBPF, but we hope that the stuff that we provide can be an example to other people who want to use eBPF themselves. And so you can look at our repo and see what we do as an inspiration for how you can also incorporate it.
Okay, and I'll just put up a comment from Noel, who's enjoying my errors there on core DNS. I never said I would produce a fully working cluster. Just enough. That's as good as it gets.
It's not uncommon.
Well, Kubernetes is hard, so. All right, so we've got links to the Grafana data source plugin here. Looks like we've got some API documentation. Oh, the Go reference docs, okay.
Yeah, so basically we have client libraries if you want to automate pixel scripts and use the results to drive CI/CD stuff, or we have a tutorial to set up a Slack bot that can ping you with results of pixel scripts. That can be a pretty quick way to get alerts about what's happening in your cluster if you wanted to have been warned sooner about those 404s or something like that.
I mean, I'm not going to sit and work through all of this documentation, but I think I'll be playing with this at some point in the near future. You mentioned alerts, and there's the Slack alerts tutorial here. Do you want to work through this and take a look at the process involved there, maybe setting up an alert? Like, I don't think we need to throw it to Slack. We can use a HTTP bin or something, but unless it's a Slack function, I'm not actually sure.
Yeah, I mean, so for this tutorial, we've actually made all the boilerplate to do the Slack pinging and stuff like that. So it might be easiest to do. So, we don't have to do it, but this is just a quick way of basically looking at 400 errors in your different services and just being alerted to that. I did it in a few minutes last night, and it's pretty easy. So we can dive into this if you think that that would be a good thing.
Well, yeah, I think, what we've shown so far, let me just close that one, is, Pixie is already collecting a wealth of information on my cluster, and I haven't done anything. All right, so we've got a big, massive tick there. Like, I want this. We've now been taking a look at the scripts, and there's loads there. We could always take a look at a few more just before we finish, but there's all these different representations of things happening in my cluster. We then modified a script, and we were able to actually get a count of the 404s. We see core DNS is unhappy. And what I'm thinking is, like, there's definitely something I would want an alert from. I'd want to know if I have... I don't know if we can work out, like, the medians or what the standard deviation is and stuff, but I'd probably want to alert on something with those 404s. So maybe if we can put that together, that would show us a nice end-to-end example of what Pixie is bringing to my cluster.
Yeah, that sounds great. Why don't we just work through that tutorial and, just bang it out.
Okay, so do I need to do all the Slack setup, or can we just do the actual Pixie bit and have it?
Let me do the, I'm going to create a private channel in the Pixie community repo. And then we can I'll create the Slack bot on my side.
Okay. Yeah, because I just realized I don't have a Slack.
Right. So, let me just get that started, and I can send that to you. And in the meantime, you're going to want to track down the cluster ID and create an API key in Pixie. So why don't we parallelize this, and you can collect those pieces of information, and I can help you find them if you have trouble.
Okay, so should I do the Pixie deploy just now, the demo deploy?
I don't think that you have to, but
all right, okay.
I think that's just if people want to see more data, but I don't think that that's necessary.
All right, okay, that's deploying the Pixie shop demo. I guess that's a microservice thing. Okay.
Yeah, we're gonna have to make a little modification to the Pixel script because it filters on that particular namespace, but we can just quickly modify that. That won't be a problem.
Okay, sounds good. So I'm running Pixie get visiers, and I have my cluster ID. That was easy. Okay, and then now I need an API key, so I'm going to follow the docs for that too. Oh, nice and easy as well. Perfect. All right, should I clone the demo repository?
Yeah, please do.
Alright, Slack. Does it matter if I pick Go or Python?
Nope.
No, okay. I'll do Python because the instructions are Python.
There you go.
Oh, I don't have pip. Okay, we'll do Go. And all right, so export my cluster ID. Oh, I'll let that build first.
And you'll want to actually modify the Pixel script where we filter on namespace. So I would just find that in the http errors.pixel, and I would just delete that line that does that filter.
Right. Okay. Yeah, I can do that. So I need to grab my API key, and then you want me to modify this px sock. There we go. And can I just use the PL namespace?
Yep, that works. You could also just take it out altogether and just do across namespaces.
Done. All right. So I'm assuming I had to do a go build again. I'm assuming that's maybe templated in somewhere.
I don't think so. I think you can just do go run.
And all I need now is a Slack bot token.
Yes, I'm about to send that to you. But first, I'm going to create the channel.
Oh, I'm being mocked again by Noel. Come on, Noel, be nice to me. I am always flashing API tokens on this show, that's true. But I always delete them straight after, I promise. Okay, and then once we have our Slack bot token, we're going to do a go run Slack bot. And that's us.
Yep.
Easy. Okay.
Okay, I'm going to add you. And I'm going to invite the bot.
Okay, I see Pixie alerting added to the channel.
Okay, I'm sending you the code over DM.
Thank you. All right, so you're happy for me to share the test Pixie alerting channel on the stream? Mm-hmm. All right, there we go.
Oh, actually, one more thing. We have to edit the channel in the script itself, in the code, because it actually, but do the export first. Do the export first.
Okay, I'll do that over here so people don't see that. Okay, and then we want to modify our pixel script.
Oh, you did that, so that's great.
Okay.
And then could we also modify the function? Oh. It's not in the script, actually. It's in the, so if you do
Slack bot.
the go.
Oh, don't open the binary. There we go.
Yeah, so now we're going to just, so just change that. I named it test Pixie alerting. So we're going to just, great. So let's try go run. Let's see if it works.
Yeah, we did everything there.
I think so. Hey, it worked. You can maybe just show the Slack.
Oh, look at that. So Pixie alerting sent us a message telling us that we had 4xx spikes in the last 5 minutes.
Mm-hmm. And you can, obviously, make it more conditional and things like that, or run a different script. But, we just wanted to kind of set up the full end-to-end thing for people with an easy-to-use example that they can then customize to their case.
Okay, so, I mean, that's the exact thing that we discovered with my core DNS. Was that just complete serendipity that that's what the alerting script was set up to be?
I think a lot of people are interested in HTTP errors.
Right, okay.
So I would say it's serendipitous, but I would also say that, we try to target a common use case.
Okay. Are you happy for us just to kind of take a look at that script and actually see what we have here?
Let's do it. Yep.
Okay, so we've got an import PX. I'm assuming this is just our Pixie data frame integration thing. Helper
so
functions.
that's basically the module that we, provide.
Okay, the table is the HTTP events. So how would I find what that table is from my Pixie UI? Like if I've got data that I want to start writing my own Pixie script from, or would I just copy it?
Like, are you saying, could you just copy the script itself?
Yeah, I was curious. How do I know what tables I have available?
Oh, okay. Here, let's scroll up. And we're going to exit out of this one if that's okay. And go to px/schema. Oh, I see you already scrolled up. I was the one scrolled down. So in here, what you can see is all the different tables in Pixie and the description of what they do. And then in the next table, you can see all the different columns they have and what you can find out about them.
Okay, there we go. So that's how I discover tables and columns that are available for me to put in my script. Okay, got it.
Yeah, because that's not something you could just infer. We have to document that. I mean, it is documented, but we also want it to be programmatically generated as well.
Yeah, that makes sense. Okay, so much like the web UI, we've got our start time here. Now we're looking for greater than 400. Again, that was just complete luck that we happen to have the same query, but like you said, it's a common use case. It makes sense.
Yeah.
Now,
I promise it was legitimately already that way for months.
okay, so now we're pulling things from our data frame context into the top level data frame. I'm assuming that's just because we want access to the namespace and the service and the data that we're working with. And then we have our group by service, aggregating the error count and total request count. Okay. And then we get PX display. What does PX display do? Is that can I tweak that to display different visualizations?
Yeah, so basically the way you can think of it is there's two ways to write a pixel script. The first is with a viz spec, which is what you see if you want fancy charts and things like that. But the second is if you're lazy like me and you just want to produce a bunch of tables, you can use this way. And in this way, we'll basically say that anything you call px.display on will just be outputted.
Got it. Okay. Now, I could just run this in the browser to like get live feedback into what I'm doing and then move it into like the Go tooling and do things that way. So like the UI would be a good way to build these out, and then I could put them into other tooling. Is that what you yeah, okay. I'm glad I understand that then. And now with regards to the Go code here, is this just using the Pixie API to be able to coordinate setting up the alert and then publish to Slack? Okay, so the Slack alerting code isn't something that's available in like the PX module. It's just regular Go code. Okay.
That's right. Because the pixel scripts, that's for querying data. And then because of the API, you can embed those results into whatever control flow logic you want.
Okay. The full picture now is starting to cement in my mind. So I've got Pixel, I can query the data, I can build my visualizations, and then we've got the Go and the Python SDKs if I want to be able to take that tooling to my own infrastructure where I can do alerts and a whole bunch of other things.
Here's something quick we could do actually. Let's just run that pixel script with the CLI just so you can show the interoperability. If you just do px run and then -f to save file and then HTTP errors, it will just run and produce the results in the CLI.
I changed directory, so I need to
okay.
Do Pixie 1 cube. Ah, nice.
So that can be another way to iterate on it. And we have I would compare another version of another command in CLI that's like, I would compare it to like K9s, where it's like more interactive and you can like switch scripts and drill down easily. But just for the purpose of this, it was just kind of easy to do px run. And the one I'm referring to is px live. So you want to do Control K and then just select a script. That's a good one. But any of them, honestly, yeah, that's good.
Oh, nice. All right, I'm running out of adjectives for being impressed here. You're going to have to slow down. I love that I can work in a pretty feature-rich way from the command line or the UI or even from the SDKs. Like, as a developer, just having those availabilities to me and being able to work and what works best for me or my team, my organization. Yeah, this is just pretty well-rounded. I'm really impressed with this. How is this just a startup? I don't get it. It feels more mature than that.
Well, I mean, we're no longer a startup. We're now part of New Relic, which is great. Of course. But yeah, when we were acquired, we were, I think, 10 or 12 people. So, we're just really passionate about making this a great experience for developers like us, is what I would say. Yeah,
normally when I have, companies that are relatively new, they're like, okay, like don't click on this and don't run this and don't do this. And everything we've done here has just worked right out of the box. So very nice. Okay. I'm guessing, I don't know, have we taken a look at most of the functionality, or is there anything else you would like us to look at before we wrap up for today?
I could go on and on, but I think that, for the benefit of the audience, we can call it here, and we can just say that anyone who's interested in learning more should check out our docs or our GitHub repo. Please file issues for problems that you see, and we'd also love for people to join our Slack community.
Awesome. Yeah, I will make sure there is a link to the Slack community in the show notes. It's also available on the Pixie website. And yeah, you should all just definitely go check it out. You've seen now in the last hour how easy that was to get started, and the features just keep coming. We got one question in the chat, but I think we already answered it, but I'll do it again just in case Bogdan missed the start. But can the whole stack be self-hosted? And if not, is it on the roadmap?
Yeah, would love to emphasize this. Pixie is entirely open sourced. So even though we went with the free hosted option today, you can entirely self-host it. And, the instructions for that are in our docs, or you can check out our GitHub repo to learn more about how to do that.
Awesome. All right. Thank you very much, Natalie. That was a great tour of Pixie. There was a lot to love there. Definitely going to be kicking the tires on this more with some real clusters. I just want to thank you for taking the time out of your day for guiding us through this and sharing your knowledge with us. It was an absolute pleasure.
Yeah, it was really great, diving into it with you as well. It's always fun to see it from a new perspective, like from someone who hasn't looked at it before, because I look at it all day. So,
All right. Well, thank you again. Have a wonderful day, and I'll speak to you again soon.
yeah, thank you so much.
Bye.